Good afternoon to doctor. My name is Darren John, son of Henry John. My metric card number is 210335. Today I'm going to give the introduction to rainfall. Rainfall defined as it is a form of precipitation that occur when water vapor in the atmosphere become into droplet that can no longer be suspended in the air. Number two, how the clouds are formed. Moisture or water vapor is moved upward in the air mass by turbulence and converted into cloud. The cloud eventually releases the water vapor which fall as rainfall. And number four, falling rain is often made up of droplets. The droplets have their own diameter. For example, about 0.02 in bracket, which is 0.5 millimeter or more. The hydrological cycle, which is a non-stop movement of water below, on and above Earth's surface. The cycle involves water stored firstly in the sea, but underground, for example, lake, river, and glaciers. Objective of this research is to determine the impact of mean aerial rainfall on a moderate rainfall. Number two, to explore how the process of rainfall changes from cloud to water. Number three, the type of rainfall. There is a lot of type of rainfall. The specifically three things that I have took is convective rainfall. Number two, orographic rainfall, and frontal or Ceylon rainfall. Okay, this is three type of different rainfalls. And number four, factor affected rainfall. The factor affect the rainfall is latitude, temperature, moisture, air masses, different heating, and lastly, mountain barriers. Okay, for the method or equation part, I use recording rain gauge, which is a weighting bucket rain gauge, which is N representing the optimal number of rain gauge, which is the first formula. The second formula is CV, which is representing the coefficient of variation of the rainfall value of the gauges. This is the result for the weighting bucket rain gauge, which is you can see its total rainfall versus the time, and on the peak of the graph you can see the pen reverse direction. Conclusion, we learn process that combine hydrological cycle are rainfall, infiltration, steam flow, and groundwater measurement, and finally our objective is achieved. Thank you.
Infiltration. The term infiltration refers to the process of gaining access to the soil by flowing downward through the entire or a section of the soil surface. Gravity and capillary action are the driving forces in these systems. Because small pores absorb water through capillary action and against gravitational force, they have a higher resistance to gravity. How much water enters the root zone and runs off is determined by the rate of water supply and process. Objective is to determine the infiltration rate of water into the soil in the particular area. Study area. To continue this project, we have decided to select our set study area at FK Parking Area UTHM. Measurements of infiltration rate were carried out with double ring infiltrometers. Infiltration is the process by which water on the ground surface enters the soil. An infiltrometer is a device used to measure the rate of water infiltration into soil. Equipments to conduct this test are the double ring infiltrometer, hammer, stopwatch, ruler, pail, and water. Procedure to conduct infiltration test are: the ring is driven approximately 5 cm into the ground, water is applied inside using a constant head device, and intake measurements are taken until a constant rate of infiltration is achieved. Results. For the dry soil, we can see that the infiltration occurred faster than other soil. This is because water is easier to absorb to the dry soil because inside the soil they have a lot of void. Next, for the wet soil infiltration, not too fast. It is slower than saturated soil. This is because they already have a water inside the soil. Then, for the saturated soil, infiltration occurred very slow because they have a lot of water inside the saturated soil than the wet soil.
My name is Phrisillia Mujan and I will explain a little bit knowledge about stream flow. The most significant basic data for hydrologic research is stream flow, which represent the run-off phase of hydrologic cycle. Stream flow measurement, in the other hand, can be reasonably accurately accessed. Stream flow is the only portion of hydrologic cycle that can be properly quantified. It is crucial to measure and document because it is used to calculate water budgets, scarcity, flood risk, and general loading of suspended or dissolved contaminants. There are also ways involving weirs that can be used to estimate discharge but not velocity, because flow velocity varies at different points in stream cross-section. Velocity measurement must be taken at several locations to capture the complete range of values. A timer and certain additional equipment are required for all flows measurement. The objective is to measure volumetric flow rate and mean velocity of small local stream. The justification of method or procedure are: first, read the quick guide to use the velocity flow meters. Second, decide on the width of the cross-section will be used. Third, measure and record average depth of the first cross-section and decide if velocity should be measured at first depth or the second depth. Fourth, measure velocity at the first or second selected depth. Next, repeat step 3 for each cross-section, and lastly, calculate the stream flow using the equation. Equation for stream flow measurement would be Q, discharge equals to A, area, multiply V, velocity, where A are the cross-sectional areas of subdivision, V are the average flow of velocities of subdivisions. For the result and analysis, the table below shows data from a stream gauging operations. For the stream flow conclusion, the approaches for determine vertical mean velocity have an impact on velocity observation. The velocity distribution method, 0.6 depth method, 0.2, 0.8 depth method, 6-point, 5-point, and 3-point techniques are all examples of these methods. The velocity method of discharge measurement entails measuring the area of the reverse cross-section at a specific location known as gauging site, as well as velocity of flow. Obtaining a continuous record of stage, taking periodic discharge measurement, and applying the stage discharge relation to the stage record to produce a continuous record of discharge are all part of stream gauging.
Hi, I'm Vasunthra. I'm going to explain about the groundwater. Groundwater velocity by using Darcy's law. Groundwater is a water that fills pores and fractures in the ground. Top water of groundwater level is called the water table. Between the water table and the land surface is the unsaturated zone. In the unsaturated zone, moisture is moving downward to the water table to discharge the groundwater. The water table can be very close to the surface, within a few feet, or very deep, up to the several hundred feet. Okay, groundwater science is complex and several types of information required for a complete understanding. Hydraulic height, which is simply the elevation of the water surface in a well relative to a specified elevation, datum such as a sea level. When height is combined with basic geological properties like hydraulic conductivity, groundwater flow direction can be deduced and good starting point for investigating all type of groundwater level situations. Okay, fundamental of Darcy's law, hydraulic head, hydraulic gradient, and potentiometric contours are presented conceptually and visually, transforming intuitions into knowledge with minimal mathematics. Okay, groundwater level Darcy's law can be used to produce rough estimates and working hypotheses. In modeling, differential equations are formulated by assuming the equation determine flow in each point in an aquifer. How long it takes when maximum impacts of groundwater pollution emerge around falling ponds without sealing bottom structures. Darcy's law can expresses the relation between hydraulic head differences and hydraulic conductivity. Below is the formula where Q discharge volumetric flow rate, H hydraulic head, L distance, A cross-sectional area, N equals to porosity, Q equals to Q divided by A, which is a specific discharge equals to flow per unit weight. Flow is therefore driven by negative gradient of hydraulic head. Conclusion: we learn process that merging precipitation cycle, evaporation, infiltration, stream flow and groundwater measurements. Our objective successfully achieved. Thank you.